Good evening. Welcome, everybody. My name is RP. I am the moderator of today's event. This is actually the last event of the grid community of this year. Hopefully, we'll have more exciting conversations in the upcoming years as well. I'm representing Apex Lab. We're a software development agency heavily involved in the energy industry. We created this community to bring a more pragmatic approach to enhancing smart grid technology. We want to showcase real-life projects that contribute to this goal. And obviously, we want to bring energy professionals together and initiate the conversation. My guest today is David Wyatt, the simulation lead at Energy Systems Catapult, and Dr. Priya Bhagawati, lead R&D engineer in Whole Energy System at PNDC. We will start with a short presentation from David. He will share some insights about Catapult and VESA and how their living lab actually work and how that collaboration works with PNDC, and obviously how that can contribute to helping innovative organizations and businesses to test their products and services in a real life scenario. Afterwards, we planned a little bit of a short free flow discussion where we'll get to know David and Priya a little bit better. And at the end, we'll give the floor to the rest of the audience to ask your questions. I was thinking the same thing. The floor is yours, David. Thank you very much for joining, and feel free to start the presentation.
Thank you very much, RP, and thank you for the opportunity to come and give this presentation today. We're really glad to be able to talk about the work we've been doing, and we're really keen to hear views from other people who've joined the call today. So, as RP introduced, my name is David Wyatt. I'm from Energy Systems Catapult, and I'd like to talk to you this evening about how we're enabling energy innovation testing across the whole system. So I will start by talking a little bit about the two organizations that are part of this project. So I'm from Energy Systems Catapult. We are a not-for-profit organization based in the UK. We are partly funded by the UK government through an agency called Innovate UK. And our mission is to accelerate net zero innovation. So the way we do that, to use a phrase that you'll probably hear quite a lot of in the course of this presentation, is by taking a whole systems approach. So we are firmly of the view that the challenge of net zero can't be solved by thinking in silos or working on one area at a time. You have to take a broader perspective that takes into account the interactions between different parts of the energy system. And so the philosophy that we pursue is actually kind of twofold. So a large part of our work is supporting specific energy innovations. The slide says turbo boosting innovation. That could be at the level of small companies with new ideas. It might be local areas or industrial or commercial sites that want to do something different, or even at a larger scale. But we also want to look towards the wider system, the regulatory and policy environment that creates the climate for energy innovation, and help the stakeholders who have the authority to design that climate to shape it in a way that will encourage innovation to bring about the net zero energy transition, to design a future energy system to drive clean growth. So that's Energy Systems Catapult. PNDC, I will talk on Priya's behalf here, but please feel free to jump in if you'd like to add anything else. So Priya represents PNDC, as I say. They are an organization within the University of Strathclyde, also based in the UK. They have a physical facility near Glasgow, opened 10 years ago, so they've been celebrating their 10th anniversary year this year. And actually, in the last few days, they have announced that they will be opening a new facility to expand their operations, also in the same area near Glasgow in Scotland. They have a broad focus across technology development of energy, marine, and aerospace. And in particular, in the bottom right, you can see that they focus on the kind of intermediate stage of technology development, following on from what might be early stage academic research, but where technology is not sufficiently mature to be taken up by industry as business as usual. That's where they come in to help get the technology through that transition and development process. And so they work very much in partnership with industry on their projects. Priya, is there anything that you'd like to come in to add to that?
Thanks, David. You did a wonderful job explaining. Only point I would add is, like, mostly we talk about digital twins. PNDC is all about hardware twins. So we have a replica of a distribution network, and in the new facility, we would have a replica of a thermal system, including heating and cooling, and also potentially a route for hydrogen. So we are mostly looking at, yes, simulations show us this is what we expect. In real life, including all the hardware, is it giving what we expected it to give? So that's how we complement each other.
Absolutely, and I'll come back to the test facilities at PNDC a bit later on, because they're a key part of what we've been working together on. So to go back and set the scene a bit about the challenge of the energy transition, I'd like to kind of break this into three different aspects, which I've tried to outline on this slide, which I think we're all familiar with, but just to kind of try to crystallize what the way we think about these things. So the first aspect of the energy transition, of course, is the very radical and very rapid changes to the way energy is produced and used within all parts of the world. We have quite a UK focus at Energy System Catapult, so I will probably focus more on how this relates to the UK, but of course the same applies in all countries. So the graph on the left is produced by the National Grid Electricity System Operator in the UK, showing the rate of uptake of battery electric vehicles over future years from now to 2050 as part of their future energy scenarios. And you can see the dotted line is, so this is from this year's scenarios. The dotted line right at the bottom shows what's happened so far, and then the scenarios show where we have yet to go. And of course, there are many aspects of the energy transition apart from battery electric vehicles, but that's a nice kind of yardstick of how stark a transition this is going to be about. At the same time, the energy system is critical national infrastructure. It's something where in all parts of the world it's fundamental to the economy, to how people live their lives, and it's something that we really cannot afford to risk even through this transition happening. And what I've pulled out here on the right-hand side is a slightly obscure part of this, but I think is again a nice indication of this. So this is historical data. This is historical data of the electricity system frequency in Great Britain. So England, Scotland, and Wales. Northern Ireland, although it's part of the UK, is part of a slightly different electricity system. So it's the main island of Great Britain. And so it's data from November, from last month, and from the first 6 days of November. That was as many as I could put on the graph without it getting a bit too busy. And what I think this shows is that something interesting happens every day at midnight. And there are other possible explanations. Correlation is not causation, as the saying goes. But one strong contributing factor that I believe is causing this dip in frequency is is electric vehicles, in fact. So in Britain, there is an energy supplier called Octopus Energy. They offer a tariff for electric vehicle owners, which has a discounted electricity price period that starts at midnight every day. And so what I believe we're seeing here is that in today's world, we are seeing the impact on the electricity system of the electric vehicles that are signed up to this tariff. That's the tiny little dotted line on the left-hand graph, kicking in and starting their charging and having this kind of reasonably noticeable national effect even in today's world. I'd want to emphasize this is not a risk. This is something that National Grid are well aware of, and actually the market is moving on, so this will become less of an issue in future. But it's a nice, I think, illustration of how the adoption of some of these new technologies at scale can cause really substantial changes to the system. And then the third point that I'd like to emphasize, and something that's really important for us at ESC and also at PNDC, is we want solutions for energy in future that work for all consumers. We have a particular focus on domestic consumers and a particular interest in them, but energy consumers come in many different forms. And as one of my colleagues used to say, at the end of every wire and every pipe, there is an energy consumer, and if they don't like what the supplier is giving them, they will seek changes in one way or another. So that's a big part of what we're trying to achieve with this project. So what we've been working on is an initiative that we call the Whole Energy Systems Accelerator. I should say this has been very generously supported by the Scottish Government in contributing towards the development we've been doing here. And this is a facility that we have been working between Catapult and PNDC to build a way to test energy innovations kind of wherever they might sit in the energy system, but in a robust and safe way to allow them to allow us to gain confidence before deployment. And so this facility is made of a number of components, and I'll talk about how they build up. So on the one hand, we have a contribution that we have within Catapult called our Living Lab. So this is a group of just over 2,000, nearly 2,500 households across the UK who volunteered for energy-related trials. And this is not just a mailing list. These are people who've signed up, but have also often allowed us to connect our systems to their smart devices, so we can look at their energy usage from smart electricity and gas meters, and potentially we can look at how they're using smart technology in their homes and how that technology is using energy in itself. On the other hand, we have the test facilities at PNDC. So Priya's already mentioned that they go beyond computational simulation to also multi-vector real hardware testing capabilities in a very reconfigurable way. And so this gives us the ability to understand the impacts on real infrastructure, or computational simulation if that's appropriate, but safely separated away from the real energy system. And then the new part that we've been building through this initiative is the digital infrastructure that links the two together. So this allows us to create energy system scenarios that are different from what we have in the world right now. And I'll talk a bit more in a moment about how that works. But what this allows us to do is to take real consumer behavior and apply that to energy infrastructure, and at the same time take an understanding of the state of the infrastructure and use that to inform the offering to consumers. So to think about smart usage of energy to in the best interests of the system. And the great thing about our living lab capability is it allows us to understand the actual consumer experience there. So so how do households, how do different sorts of energy consumers find that these new emerging energy technologies and energy propositions that are starting to exist work for them, and do they give them the outcomes that they want in terms of their everyday lives? So I said I'd talk a bit more about how this works in practice, and some of the levers that we have with WESA in terms of defining future energy scenarios. And we talk about this in terms of a feedback loop. So a loop has no start and no end, but I'll start at one point here, which is if we want to define a future scenario, we can choose specific homes or specific samples of homes from within our living lab to match what that future scenario looks like. So sticking with the thread of electric vehicles, we can choose a sample of homes such that 80% of them have an EV and 20% of them have 2 EVs. And we can choose those as representative of our future mix of domestic consumers, for example. We then monitor energy usage in those homes in real time through the digital systems that we have. And we can then remap the usage from those homes into an energy network scenario represented at PNDC, either purely inside a computer or with the addition of real world testing through power hardware in the loop techniques. We can then, we can run models to emulate energy markets and the wider energy system beyond the specific network that we're representing at PNDC. And then finally, as I've said before, we can create the consumer experience of new energy propositions. So if there's a proposition where usage of smart technology is dynamic and adapts to the needs of the wider energy system, we can make that happen. We can give consumers that experience. One of my colleagues calls this creating a future world that the consumers can live in, and we can get an understanding of how they find it. And then finally, kind of drawing all these things together, we can explore both the technical outcomes for the energy system, for assets within it, but also, as I say, what consumers think about this new world. So talking about some of the levers we can pull, I've already talked a little bit about the mix of house types or home types and the in-home technologies. So we can also, if there's an interest in trialing a specific new in-home technology, then we can find homes within our living lab who are happy to trial that technology. I'll give an example of that in a moment. But also different demographics of people and of the homes they live in. At the network level, we can construct an archetype of an energy network, energy infrastructure that might exist in future, that might be different from today, might have new capabilities added to it, it might be a more reconfigurable network or a smarter network than exists commonly right now. We can look at policy and regulatory changes in the wider energy system, as well as the ongoing trend away from fossil fuel generation towards renewables, for instance. And then finally, we can create these new propositions and represent them in a way that can make it feel real for consumers. And for people who are familiar with the idea of energy flexibility and kind of encouraging dynamic usage of appliances in response to system conditions, it will come as no surprise that this is one of the main areas where we see WESA as a valuable test facility to be able to trial these new propositions and understand the wider system impacts before rolling them out, as I say. So I've been talking about EV charging quite a bit. That has been, again, one of our early focus areas. It's one of the capabilities we've got within the Living Lab at the moment. And through the models in what we call our market emulator, we can represent different propositions that lead to smart EV charging in response to wider energy system conditions, particularly focusing on the interaction between what in Britain is called the distribution network operator or distribution system operator, the retailer, who in Britain is separate from the network operator, and then of course the consumer. And then that we can run that all the way through up to and including producing a simulated bill that we can send to Living Lab homes and actually show them for their usage pattern under this new proposition, what might that mean if this proposition was happening for real. So I've got a couple of case studies, projects where we're using this capability, but it's very much a capability that is kind of available for wider use by others in the sector. So the first one I'll talk about is a project called Project Extend, which is about future smart electrified heating systems based around air source heat pumps, but with really large amounts of thermal storage included in the system to allow for much more than you'd normally find in a heat pump based domestic heating system, with the idea that you could actually be very flexible with the times when the heat pump is running and consuming energy from the grid relative to the times when the household wants heating, because the heat store acts as a buffer. So the technology in this project comes from a company called Sunamp. They're again UK based, quite local to PNDC, but working with ourselves and other partners, funded by the UK government through the Department for Energy Security and Net Zero as part of the longer duration energy storage project. And the way in which we're using WESA here, so we want to so the project is to install some tens of these systems in Living Lab homes to actually trial how they can be used in practice, but also then using WESA to create a scenario where these systems are working together to manage network capacity in a distribution network. So with the growth in electric heating, that will not only impose increased demand on electricity generation at the national level, but also local networks will be pushing up against their capacity limits in terms of the amount of throughput that they can supply. So what we want to show is that by managing the operation of these heating systems smartly, we can accommodate more systems within a given network than we would do if it was just operating in a less smart mode. Sorry. The other project is called Neighborhood Green, which once again is once again related to electrified heating. This is another major area of interest for both of the partners in the collaboration. And here we were looking at more conventional heat pumps and understanding the network impact or the electricity network impact of those heat pumps' demand profiles, both in a normal winter and in a more extreme winter where temperatures might be very low, but the heat pumps might be are still needed to provide the heating to keep the households warm. And in particular, a metric called After Diversity Maximum Demand, which is used in network planning in the UK. That's the end of the presentation. Thank you very much for your attention, and I'd be very happy to have any questions or to have a follow-on discussion.
Super exciting. Thank you very much for sharing all this, David. Very nice to see how the whole system kind of connects and then loops back to the consumer and then starts all over again, kind of fine-tuning everything along the way. So I do have a couple questions on my own, but before we jump into those, it would be nice to get to know you and Priya a little bit better. So if you could share some thoughts, how did you end up in the energy industry? What's kind of the road, and what do you exactly do at the moment? That would be great to understand.
Absolutely, yes. I'm happy to go first. So I joined Energy Systems Catapult about 6 years ago. Before that, I was actually working in quite a different sector. So I was working in consumer product innovation. So I was working for a company called Dyson in the UK, looking at how we can take really cutting edge advances in my case, robotics and artificial intelligence that were coming out of university laboratories and make them robust enough, make them reliable enough, and also make them affordable enough to be used in a domestic setting. So actually turning these really high technology ideas into something you can buy off the shelf, off Amazon, or off the shelf at your whatever home appliance store that you might choose. So I come to the end of a project there, and I had been looking to develop my career and move into a different sector, and I thought that the energy sector was one where there were plenty of problems to be solved, plenty of ways that I could contribute, and so I moved to Catapult at that point, and took on the work in energy system simulation that has kind of developed into the work that I'm doing now, with a view to I suppose trying to provide some of the underpinning detail for how some of these future scenarios that we talk about can actually come about and actually support the engineering that's being done by colleagues like yourselves. Priya,
great, thank you.
Over to you.
Indeed.
Thanks, David. So, hi everyone. I am Priya Bhagwati. I'm currently a team lead at PNDC. But I'd start my history like from my undergraduate. So I did my undergrads in electrical engineering and was very keen on energy systems, and decided to pursue my master's in energy systems, where I got exposure or introduction to mechanical engineering, chemical engineering, and how that interacts with the electricity network. So that was my early introduction to multi-vector energy analysis, and then went on to work as a system design manager for solar PV systems, looking at isolated power systems and also grid-connected systems. Some of the unique examples include like designing DC water pumps for remote villages so that they need water in the peak summer, and it was quite a well-aligned use of solar systems, and also solar systems for telecom towers in kind of very isolated villages so that they had the mobile coverage. So there were two unique applications which we designed, which was nice. But then I decided that I want to pursue my postdoc PhD and came to UK, where I did my PhD on impact of PV again on the electricity network, so more power system, interactions with the grid, looking at the demands, and then went on to do my postdoc at the University of Oxford, where I was exposed even further to electrification of heat, electrification of transport, and how that interacts with the energy sector. And my interest with the energy systems is because of the climate change. We all are quite looking forward to reduce the emissions in total, and To me personally, climate change impacts are something which I can already see in my hometown. The beach that I used to play no longer exists because of the water level rise. So it is quite disheartening when we go home to see that, okay, that no longer exists. So I'm hoping that some level of innovation support and accelerating the technologies can make an impact longer run and maybe save some more beaches for the future generations. So that's me.
Thank you, Priya. Well, let's hope it's not just beaches that we might save in the future.
Yeah.
Super exciting. In terms of kind of this whole ecosystem is working. I've seen some additional names there, like My Energy and SunEmp, and so you obviously work together with companies as well. So how does that really work, and how much is your own kind of innovation, and how much is like other companies working together with you? How does that work exactly?
Absolutely. So we we work very closely with other companies and partners in the sector in kind of two different ways, I suppose. So one way is that we collaborate on specific projects. So I mentioned the Extend project, where we're collaborating with a number of partners, and we're working together. As I say, in this case, SunEmp and My Energy working together have created the real innovative technology. I didn't talk about My Energy's component, but that's they're providing some of the kind of some parts of the heating system that goes into homes, but also some of the cloud-based solutions that enable the smart behavior of the whole system. And then we are providing a way for them to test that in the living lab and using the WESA facility. So in that case, we're very much collaborating. We also work with third parties to provide access to specific pieces of smart technology. So rather than building our own interfaces to, for example, smart meters, we work with other companies who've done that work and actually are able to grant us that access through their platform. So we're actually kind of using their services to support the operation of the overall facility, and that obviously is a very good way for the system to work. And I see there's a question in the Miro board about whether the software is custom or if it's off the shelf. Again, some of the software is custom, but also where there are off the shelf solutions that we can use, we very much try to use that. So on the Catapult side, the kind of core data collection and analytics platform under the Living Lab is an off-the-shelf product that's kind of tailored for that purpose, particularly in the area of smart energy. And we've been working very, very closely with the vendor of that technology to help them customize it to meet our needs. And then we, as an organization, have developed our own kind of custom layers on top of that to do further tailoring and make it fit our uses more precisely. Priya, do you want to comment on that from your side?
Yeah, I can comment on like how we work with the industry. We work mostly with the innovation that most of the companies bring to our platform. So the IP is most likely owned by the company who is bringing it. We don't infringe on their IP or anything. But there are also occasions where it is a grant-funded project where the government has funded, and then the IP is co-owned between the SME or the innovator and PNDC. There could even be instances where one thing inspires a new innovation, and then that would be between whoever is the researcher who worked on it alongside the company to agree upon how they want to, or like how much inspiration the current problem provided them. So we preferably work in a way that it is either industry-owned IP or mostly joint IP. So that's how we work with industry. We work mostly on commercial basis as well, like one-to-one contracts or grant funded. We go for like less than 20 to 30% as grant funded and majority commercial ones. The other one was about softwares. We do have our own models, but mostly it sits within the RSCAD, which is connected to the real-time digital simulator. Most often we own those models because it's quite a unique piece of equipment which connects to the hardware. And we would have the models of the systems, which would then talk to our model of the network instead of, it would not be that we develop our own models of of whatever technology we are testing. The technology would be, again, another piece of hardware. The network will be another piece of hardware, and we'd have the control system like SCADA or a replica of a SCADA running in the background, which controls everything.
Great. I saw you had a question, Greg. If you want to ask, you can feel free to go ahead.
Yeah, so thank you very much, Priya and David, for the presentation. My question would be really that I'm really interested about those off-the-shelf solutions and products. I'm wondering if you could share some information on our Slack or our LinkedIn about those, if it's possible.
Absolutely, yes. So I can share a bit of information now, but I can also put some links on there. So for so from Catapult side, we're working with a company called EV.energy to enable some of the smart electric vehicle charging activities, and so they give us access to data from usage of EVs, but also the ability to manage the charging of EVs in homes within very tight limits, of course, and we would only do actions like that with the consent of Living Lab participants who are taking part in a trial. We also work with, for example, a company called Tardo, who provide smart heating controls. So we can look at interior temperatures in domestic homes, in different rooms, and also look at how households are using their heating. We've done some analysis that we published about, for instance, the impacts of the recent developments in energy pricing on how people are using their heating, and whether people are using their heating less after the sharp increase in retail prices compared with before that change.
Thank you, David, and thanks, Greg, for the question. So just kind of trying to simplify it all in my mind. So you basically have the Living Lab where you can understand kind of consumer behaviors and how they react to specific innovations, and then PNDC basically provides you with a facility that you can kind of test that in a scalable way and in a safe environment. And then at PNDC's level is where you find all the findings that are related to the networks potentially. So how do you share those findings, and who do you contact to share these? And does that have any effect on how network operators would potentially think about the future, or how all does that work?
That's quite a few questions in the same question, so maybe we pick bits of it at a time.
Yes.
So I can answer the part where how do we inform the results or outputs. It is dependent on who is funding the project. So for example, for the neighborhood green project, it was a NIA funded project. So all the results were directly to UKPN, which is the network operator. So it was funded by the network operator themselves. So the results go directly to them. It is also available as open access publications on the ENA portal. So anybody can go and have a look at it. And we at PNDC also run something called as innovation forums or knowledge exchange forums on a regular basis, like 2 to 3 times a year, where we invite mostly network operators. So just for history fun, PNDC was set up as Power Networks Demonstration Center with funding from Scottish Power and SSEN. So they both play a significant role in whatever is happening in PNDC and are quite actively involved at every stage of our work. So we are shaped by the challenges that the network is facing, but equally the network operators learn very heavily from the outputs that we produce, which helps them decide what the next steps are. So I guess that covers mostly the network operator and wider. On the innovation forums, we have also started inviting all the different SMEs with whom we have engaged at different stages, and also government representatives like ScotGov and BASE or DESNES now. They keep changing the name every year. So we do invite people from them and Scottish Enterprise to attend and learn from what we do. The last type of dissemination we do is some of the case studies also go into what the University of Strathclyde's curriculum is. So on the wider basis, some case studies go into how the upcoming generation learns about the challenges.
Thank you. That totally answered all my questions, actually. And I'm really happy to hear about kind of the forum's solution, where you always kind of share your findings and have open space for people to talk about, what's exactly happening. Kind of going back to the companies joining, working together with you. So how does someone end up working together with you? Is there like an application process, or there's just a conversation to start, or you're on the lookout for innovations? How does that work?
That's a very good question. So from Catapult's point of view, one of the main parts of our work is trying to support innovators in the energy sector. So we have a number of routes that we try to kind of make innovators aware of the support that we can provide. We don't kind of we sometimes go out and actively kind of seek people to provide a specific service to us, but in terms of kind of making the Living Lab and the WESA capability available to potential users, we try to make them aware of that, and then if they approach the Catapult and would like to work with us and would like our help in demonstrating their solutions, then we can work out whether doing a trial in the Living Lab is the right way to provide that support, and if so, then there are different ways that we can actually kind of secure the resources and the kind of freedom to work with them on delivering that. So I mentioned, for example, the Extend project was funded by the UK government through a program that they're running to support technology development in connection with long duration energy storage. There's a whole discussion about what does long duration energy storage mean, but that's the name of the competition. And there have been other routes. So Priya mentioned the NEA route, the Network Innovation Allowance, it's called, which is a mechanism in the UK for electricity and gas network operators to fund further development of innovations. So we kind of try to matchmake between people with innovations, routes to actually run a project and demonstrate that, and then kind of make the capacity available in the Living Lab.
Super exciting. And from PNDC's point of view, I'm assuming you are working very closely with Energy Systems Catapult, but you also work with other organizations and companies as well, right? So how does that work? How does somebody go to you and say, we want to kind of test on a larger scale what we do?
So there is a contact us pages page on the PNDC website. So that's like, if you are finding us through that, then that's the easiest option. It is quite well monitored. So anything that goes into that box comes to the respective team leads pretty quickly. Overall, our organization, we have got 6 different teams or 6 different areas in which we work. We have got people working on future control room, active power networks, decarbonization of transport, hydrogen, power electronics, and also whole energy systems. So that's like the 6 different themes. And we have a dedicated business development and commercialization team who actually engage with the industry and be the bridge between technical and the commercial aspects. So they would be looking at all the contracts, the costing aspect. We give them an estimate of how much the effort goes into, and then they work out what kind of contract is best suited for that particular project, and then they go forward for it. So I'd say the easiest way is just reach out to us either on our website or on LinkedIn page. We also are quite actively available at most of the conferences. So the Energy Innovation Summit is where we get a lot of inquiries and a lot of contacts. Then the next one is the All Energy Conference in May next year, which happens in Scotland. So it's like those 2 are the major ones, and those 2 are also quite well attended by the network operators. So if there is any innovation which are looking for the network operator support as well, then these 2 conferences would give you an advantage in terms of meeting the same or similar people again. So you are quite getting into that group is quite critical here. It's a small group, so you just want to be in the group to make the next step. So we have a good presence on those conferences and also social media.
Of course. Well, I think the contact us was fairly straightforward and the easiest way to just reach out. Thank you for sharing all this, Priya. I'm kind of looking at everybody else. If you have questions, feel free to raise your hand. And Balazs does have a question, so feel free to go ahead.
Oh, hello. So thank you very much for the talk and your insights. I'm someone who is just new to the topic, this whole energy innovation, the whole smart energy ecosystem. And I'm wondering if there's any essential material or any recommended resource that you would highlight to someone who would like to know more about the ecosystem. Any recommended readings or resources? Thank you.
Okay, I'll have to just take a question again. Like, is it about the electricity ecosystem altogether, or are we only talking about the flexibility side?
I'm interested in both. So if you have, I'm guessing there are some, essential Bible type materials that are more general. But if there's any resource that you are following to know more about the flexibility market, that is also quite useful.
It's a really good question, and I'm not sure I've got a good answer to it, I'm afraid. Priya, I'd be very interested to hear what you've got to say. So one thing, and partly I think that's because this whole area is quite new, and so there are new developments every week, every day in terms of new initiatives being created and kind of changes to the way that flexibility is provided and used both at the commercial level and at the physical level. So I came across an initiative just the other day called Energy Cloud, which I think is getting going in Scotland at the moment. It's more established on the island of Ireland, so both Northern Ireland and the Republic of Ireland, where they make use of wind generation that would otherwise be curtailed because the system can't accommodate it and actually try to make productive use of it. But that, I quote that as an example of how rapidly things are changing.
Maybe a thought leader that you can think of that you are.
So one organization that apart from Energy Systems Catapult, of course,
Okay.
one other good thought leader in this space is a company called Cornwall Insight, and they actually run training courses that are widely accessible and open to anyone about different parts of the energy industry, including the world of flexibility and smart energy and kind of how that is developing and carrying on with it, carrying on changing. I'll stop there and see if Priya's got any better suggestions.
There is no comprehensive place where you can go to look at all the details of the electricity market. It's quite evolving. The key ones that if you're looking at just keeping yourself up to date, then it is the National Grid ESO's electricity markets and their consultations. So it gives you a view of what all has been happening in the electricity market historically. And their consultations will give you a view of what their plans are for the next few years and what types of markets they are looking at. Then there's also the Elexon website, which talks about the different markets, which is, both of them are a bit heavy in terms of text, but I would say they both are the most reliable places to go to as well. Cornwall Insights and Catapult's website are really good in terms of converting these very technical documents into something understandable for broader audience. But if you are an electrical engineer, then you might want to read what Catapult is saying, and then also go to the National Grid ESO to look at what is the future. So it's a combination of those. But you're giving me an idea that we did draft in a 4 pages or like a 2-pager on the electricity market to give them a broad audience a picture of what the electricity market historically has been and evolved. Maybe I should just publish it.
Seems like a good idea.
Yeah, it is complex.
All right, thank you very much.
Thanks for the question as well. We only have 2 minutes left of the whole conversation, but I do have one final question to you both, David and Priya. So what's in the future? What are the plans for the future for the collaboration and the kind of the whole ecosystem that you built up? What's the plan?
Absolutely. So we see this very much as a kind of enduring capability that we want to maintain and broaden in terms of how we can use it to support the wider sector and can carry on supporting innovation. There are further collaborations that we're working on at the moment. We probably shouldn't talk about them right now, but there are quite a few strands of discussion that are going on at the moment about how other organizations that are interested in working with what we've got, both from the kind of technology end, so new technology and what impact it has, but also from the kind of broader perspective of how do we design the energy system and the electricity system in particular to respond to the needs of new technologies, but also the capabilities that those technologies have to be flexible and to adapt their behavior in a way that's kind of much richer and much more powerful than has ever historically been the case. So I'm going to say watch this space.
Very exciting. What about you, Priya?
No, I'm very much aligned with what David said in terms of we are looking forward for this to act as like a test bed for any innovation that is happening in the electricity market space or in the decarbonization of heat or transport space, which is more meant for general public, not the industrial scale ones. We would also be looking at industrial scale ones, but maybe not through the living lab. But VESA as a whole would be a major portion of our upcoming years, and we are really hoping towards exciting times, looking at different innovation, and it's actually dealing with people. I know Claire just left, but she has pesky humans in the loop instead of our hardware in the loop. So it would be good to see what value we bring in.
Absolutely. Well, I really appreciate both of you taking the time. Super exciting solutions and kind of plans for the future, and I think it's very useful for anybody to contact you guys and try to collaborate if they have anything interesting to bring, because I think what you are offering is fairly unique, and I don't really think I've heard of a system similar like this before, especially with kind of connecting the consumer side to actually a scalable, testing side. I think that's very, very exciting. I also encourage everybody to keep on joining our events. We hold monthly events, and happy holidays, and I see everybody in the new year. Thank you again, David and Priya. Enjoy the rest of your evenings.
Thank you very much for the opportunity.
Bye.
Bye-bye.
Bye.